So the next step we take after cut to get the answer are theorems, and the first theorem is Fermat theorem. How do you remember about Fermat theorem? The denominator has to be a prime number and the numerator and the denominator has to be co-prime to each other. Now, first question that you will ask is, what is co-prime? Co-prime are two numbers whose HCF, highest common factor, is 1. Say example 17 and 19. Their HCF, highest common factor, is 1. Factors of 17, 1 and 17. Factors of 19, 1 and 19. HCF 1. 2 and 9. Factors of 2, 1 and 2. Factors of 9, 1, 3, 9. Highest common factor is 1. So 2 and 9 are co-prime to each other. Let's take one more example. 7 and 15. Factors of 7, 1 and 7. Factors of 15, 1, 3, 5, 15. Highest common factor is 1. So 7 and 15 are co-prime to each other. What do we learn from this? Two prime number will always be co-prime to each other because the factor of a prime number is 1 and the prime number itself. So the highest common factor of two prime number will always be 1. Okay, and that they will always be co-prime to each other. If this condition is satisfied, then the remainder for such condition according to Fermat theorem is 1. Once we start with this, it looks a little confusing. Okay, so let's put this in number to understand this better. 2 divided by 17. 17 is a prime number. So I'll remember a Fermat, and 2 and 17 are co-prime to each other. So the second condition is also satisfied. And the power of 2 has to be 1 less than the prime number, which is there. 16 is 1 less than 17. This is satisfied. Remainder is 1. This is what Fermat theorem states. Let's take few more examples. 3 divided by 23. 23 is a prime number and the power of 3 is 1 less than 23, which is 22, and also 3 and 23 are co-prime to each other. Since this condition is satisfied, according to Fermat theorem, the remainder for this is 1. So prime number, co-prime, and the power of numerator 1 less than the prime number, the remainder is 1. Let's apply this to certain exam problems now. 2 raised to 85 divided by 83. Okay, 83 is a prime number. Yes, first condition of Fermat is satisfied, that the denominator has to be a prime number. 2 and 83 are co-prime to each other, which means their highest common factor is 1. Yes, 2 and 83 are co-prime to each other, which just means that their highest common factor is 1. Now what do I need? I need the power of 2 to be 1 less than 83, 1 less than my prime number. So I need the power of 2 to be 82. So I'll write it as 2 raised to 82. But what is remaining then? Extra 2 raised to 3 is remaining, right? Because it is 2 raised to 85. So 2 raised to 82 into 2 raised to 3 divided by 83. According to Fermat, 2 raised to 82 divided by 83, the remainder for this is 1. 1 into 2 cube. 2 cube is nothing but 8. Okay, divided by 83. The remainder for this will be 8 divided by 83. It will be 8. Since it is lesser than 83, the same number has to be the remainder. Let's take one more example. 2 raised to 106 divided by 53. 53 first I'll see as a prime number, which is my denominator. So first condition of Fermat is satisfied. 2 and 53 are co-prime to each other. Yes, as their highest common factor is 1. So second condition is also satisfied here. Now I need the power of 2 to be 1 less than my denominator. So I need the power of 2 to be 52. But I need to reach 106. So I'll write 52, 2 raised to 52 into 2 raised to 52 into 2 square. Okay, divided by 53. According to Fermat, first part 2 raised to 52 divided by 53 is 1. Second part is also give the remainder of 1. So what am I left with? 1 into 1 into 4 divided by 53. So this is nothing but the remainder is 4. Okay, and that's how I solve the problem with Fermat theorem. Okay, so remember the conditions for Fermat. First, the denominator has to be prime number, numerator and denominator has to be co-prime to each other. Then the condition for this gives me the remainder of 1. Okay, this will be very helpful for you to solve the problems having the denominator as prime number.